Prashant Jain, and this is.
Hello everyone.
Jain. Hello, future leaders.
Oops. Hello, hello, hello. Did it stop? Yes, the stream ended abruptly. Amrendra, am I visible? Where I am live? Just a second, guys. Yes, I am live. It seems I am live. Let me open the link. Let me open the link, guys. Let me open the link. Let me open the link again. I was. Just a sec. Let me again open the link. Yes, perfect. Perfect. But this is the new link. This is a new link, right? This is a new link. Okay. So we'll merge. We'll merge the stream. Perfect. I think this is the new link. This is the new link. The stream ended somehow. So basically, I was explaining this problem. Consider the following statement in respect to two natural numbers p and q such that p is prime number and q is a composite number. P times q can be an odd number. Q upon p can be a prime number. We can simply see it with examples. And since the word is written can be, right? It is written can be. Hence, we can make it possible. If the option had will written, then this would have been an incorrect option. Okay. So the answer will be all the statements are correct. All the statements are correct. Okay. Now, let's do this. There are two containers X and Y. X contains 100 ml of milk and Y contains 100 ml of water. 20 ml of milk from X is transferred to Y. After mixing well, 20 ml of mixture is mixed in Y is transferred back to X. If M denote the proportion of milk in X and N denote the proportion of water in Y, then which of the following is correct? This is a very, very doable problem. This is a very, very doable problem, and we'll do it. And we'll do it. Right? Let's do it. Let's do it. So originally we had 100. Okay. This was water. This was milk. 0, 100, 100, 0. Right? Right? 20 ml of milk is transferred here. Okay. So the next scenario is this. 120, 100 and 20. So can you see here that the milk is in the ratio 1:5? Milk and this ratio is 1:5. So when we are transferring 20 ml of the mixture in Y in X, what will we have? We will have, see, like just reduce, like out of the 120 ml, 20 ml is transferred. So 1/6 of the liquid is transferred. So simply transfer 1/6 of this here and 1/6 of this. Just a second. 1/6 of water will be here. Milk will be 100 plus 20 by 6. And it will have 500 by 6 here and 100 by 6 here. Okay. Now you can see now what it is saying, if M denotes the proportion of milk in X, the proportion of milk in X is 80 plus 20 by 6 upon 100. Okay. So what am I getting here is, this is 420, 500 by 6, this is 500 by 6, so 5 by 6. Now N denotes the proportion of water in Y. It is again 5 by 6. So M equals N. M equals N. M equals N. Right? M equals N. This is the important part. M equals N. Okay. Okay. So this is again a doable problem. So we have done all these two problems. And where are we now? Okay, 15 out of 25 and 16, 17, 18. So we are at 18 out of 28. We have been able to do all the problems. All the next three problems have been very simple. No advanced concept involved. No, not even a single advanced concept involved. Right? Okay. A pie chart. Now the pie chart, bar charts are very, very simple. And I have seen it everywhere. In every single paper, we see problems of these. Pie chart gives the expenditure on 5 items, A, B, C, D, E in household. If B, C, D correspond to this angle, what is the percent of expenditure on A? Very simple. The total angle sum is 360. So we add all these angles which are corresponding to B, C, D, E. This is going to be your percentage, isn't it? This is going to be your percentage. You just have to add 140, 180, 140 plus 120 is 260, 260, 100 upon 360 into 100. Right? 9, 25, 250 by 9. D option. Right? 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 Kindly explain once again at that third part which you equated it. See, the third part, in the third part, what I was doing, see, like, again, you will see a system here, what I'm doing here. This was very simple, this was very simple. Now, when you thoroughly mix the mixture, right, every content will have milk and water in the ratio 5:1. So if you are transferring back 20 ml, 20 upon 6 will be the milk that is getting passed here, and 100 upon 6 is the water that is getting transferred back. X had 0 water content, so 100 by 6 directly gets added here. 20 by 6 milk is getting added here. Right? Right? So this is the total content. And since, see, like, if you see common sensically, this is 100 by 6, this is 100 by 6, the whole mixture was 100 ml, so this had to be 500 by 6. The milk content would have been like 500 by 6. So 500 by 6 upon 100 is 5 by 6. So there is some sort of fast calculation involved, but the concept is not difficult. Right? So this was 19. See, very, very comfortable. If you see in the later part of the problems are very, very doable. In the later part of the problem. Okay. Now see, if 15 times 14 times 13 times this is 3 to the power m into n, where m and n are positive integer, what is the maximum value of m? So I'm going to give you a very nice formula for this, right? Just divide this 15 by 3, you will get 5. Then you take just 5, again divided by 3, you will get 1. You have to take the integer. So this will be 1.67. Simply take the integer. Add these two. This will be your answer. This will be your answer. In mathematics, we call it Legendre's formula. We call it Legendre's formula. It's a very famous problem. But for you, if you see this type of thing, just simply see how many multiples of 3 you have. So in the 15, you will have 5 multiples of 3. Then you have 1 multiple of 9 as well. So any multiple of 9 has 2 powers of 3. So just add that power. You get 6. You get 6. Now I am willing to give you people benefit of doubt here. I think we can skip this one. Do you want me to skip this one? Like, do you want me to put this problem in a skip category or do category? Is it a do category problem or a skip category problem? Tell me. Is it a do category problem or skip category problem? You tell me. No, actually, see, like Saptashati, actually what I'm doing here is I'm seeing how many multiples I have of 3 here. 5. Then I'm taking multiples of 9. So 15 times 9 is 5 by 3. So there is only one multiple, right? So among first 15 numbers, how many are multiples of 9? Only one. And it will have 2 powers of 3. Right? That is how I'm calculating. That is how I'm calculating. Okay. Right? Then this problem. Now, what is the value of x in the sequence? 2, 12, 36, 80, 150, x. Right? 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 So, majority of the times, the algorithm will be very difficult to crack. Right? So, just see here. If you see the difference here, it is 10, it is 24, it is 44, it is 70. This is 14, this is 20, this is 26. This is 6, this is 6. So add 6 here, you will have 32 here. Add 32 here, you will have 102 here. Add 102 here, you will have 252. Do you know these type of problems? 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 Did you understand it? Did you understand it? We simply have to climb the ladder. We simply have to climb the ladder. Okay. Okay, guys. So let's put it in a skip category. What do you say? Let's put it into skip category. What do you say, guys? Is it a do problem or a skip problem? Is it a do problem or a skip problem? You tell me. Right? Reverse engineering. Yeah, it is reverse engineering only. Right? It is reverse engineering only. Okay. So there are 9 cups placed on a table arranged in equal number of rows and columns, out of which 6 cups contain coffee and 3 cups contain tea. In how many ways can they be arranged so that each row contains at least 1 cup of coffee? 1 cup of coffee. It's a very, very difficult problem. Very, very difficult problem. Right? So basically, you are putting 3. Right? You are putting it like this. Okay. So it is saying that every row should contain at least 1 cup of coffee. Right? 1 cup of coffee. Okay. Okay. Isn't it? Isn't it? Isn't it? at least 1 cup of coffee. So basically, you cannot have a row in which there are 3 teacups. Just think it like this. Think it like this. You cannot have a row in which you have 3 cups of tea, and there are total 3 cups of tea. So what I am going to do is that if I have complete tea here, and then this is coffee, right? This case, so TCC, CTC, CCT, right? This is the combination which I want to subtract. This is the combination which I want to subtract, isn't it, guys? These 3 combinations. And how many combinations I will have in total? Now this is why it is difficult. This is why it is difficult. You would not know about it, right? What is this? What is this? You would not know about it, right? So that is why it is better to skip. It is better to skip this problem, right? It is better to skip this problem. You would not know about it, right? Okay. So actually we were in a very comfortable position, I believe, right? So we have skipped these two. 19, 20 out of 30. 20, we have already achieved 20. We have already achieved 20. Even if we skip these 3 problems, let's see the 30. So we were at 32 out of 20. The sum of 3 consecutive integer is equal to. So like, what is the, guys, what is the qualifying criteria these days? I seem to have forgotten this. What is the qualifying criteria for this? 40%, right? 40 or 50% or 60%? 40, 50, what is the percentage? 40% or 50% or 60%? Right? The sum of 3 consecutive integer is equal to their product. How many numbers of possibility are there? Now this is a simple one. This is a simple one. This is a simple one, guys. Right? What do you have? Sum of 3 consecutive numbers. So always assume 3 consecutive integers as this. Right? Product of these is equal to the product. And the sum will be this. Right? This is the trick. So you will have 3n here. Right? N minus 1, n plus 1. Okay. Okay. So you will have n cube minus n equal to 3n. So n cube equal to 4n. So you will have n equal to 0, n equal to 2, n equal to minus 2. Right? So minus 3, minus 2, minus 1 is one combination. 1, 2, 3 is another combination. And then minus 1, 0, 1 is another combination. These 3 combinations. Only 3. Okay. Only 3. 66%. See, 2/3. 2/3. 2/3. Like getting 2/3 here is very difficult. In mathematics, it is going to be very difficult. So you will have to get more marks in reading comprehension. At least not in the first round. Right? We have been able to solve how many problems? 21 out of 33 till now. Right? 21 out of 33 till now. Okay. Okay. This was also a simple one. And we have done only simple ones. What is the number of numbers of the form point xy? Non-zero digits. XY are non-zero digits. Right? Now this is very simple, right? This is very simple. Right? Basically you are just, and these are non-zero digits, right? Non-zero digits. Non-zero. So it will be 81. Right? There are 9 ways to choose x, 9 ways to choose y. 81. This is 100% doable. 22 out of 34. 22 out of 34. Isn't it, guys? Isn't it? Isn't it? Isn't it, guys? 22 out of 34. Right? Right? Now let's move on. 35th problem. 35th problem here. The average weight of ABC is 40 kg. The average weight of BDE is 42 kg. And the weight of F is equal to that of B. What is the weight of A plus B plus C plus D plus E? Now, very easy problem. Just see A plus B plus C. Can you say this will be 120? Now, instead of B, it is written weight of F is equal to B. So put F instead of B. This will be 42 times 3 is 126. Isn't it? Right? This is very simple, right? 40 times 3. Why you are doing 40 times 3? A plus B plus C upon 3 is 40. Just add these 6. Right? You get 246. So 41 is your weight. Isn't it? This is again a simple one. Again a simple one. 23 out of 35. 23 out of 35. Again a simple one. Right? Again a simple one. Guys, can you all like the session? Can you all like the session, guys? Okay, perfect. So, before we start, now we will do it in reverse order. We'll do UPSC 25, right? UPSC CSAT 2025 first. We will do UPSC CSAT 2025 first. 23 out of 35. Are you done? Are you guys okay with this? Right? It is roughly more than 60%. It is almost 65 to 66, 67%. And I have proved here, and largely it is considered more difficult, right? You would agree. The mathematical part is considered more difficult. Reading comprehensions are also difficult, but this is considered more difficult. And if you are able to solve these many numbers, if you are able to get these many numbers, then it is good. Right? Okay, let's move on to the UPSC 2025 first. Okay. So now we will do UPSC 2025. We'll do 2025 first, so that we have coverage of the most recent one as well. We have the coverage of most recent one as well. Right? Right? Yes. Perfect. UPSC CSAT 2025. Okay. Okay. Again, we will do. Yes, problem is time. See, like we have chosen, believe me when I'm saying this, out of the 12 problems that we skipped, at least 6 were doable if we had another go at them. Right? I know this is see, like I have also given CSAT. The time pressure is there. I know, and it also depends. So like it is, so this type of paper is highly skewed towards those engineering guys. They have the context, they have the background in the same. I know it is a bit unfair for the non-engineering background people to answer those questions, but in my opinion, if you practice, you will be able to, because like there is some sort of repetition, and we will see in 2025 paper. Okay. Now, this problem. A natural number n is such that it can be expressed as n, p plus qr are distinct factors of n. How many numbers below 50 have this property? Okay. Okay. Now, this is, in my opinion, highly undoable problem. Highly undoable problem. Right? For example, 6 is 1. Right? 6 is equal to 1 plus 2 plus 3. right? But it is highly undoable, in my opinion. In my opinion, it is highly undoable, right? Because it is saying, see, like sum of three factors, three distinct factors. Okay, in my opinion, it is highly undoable. So we will skip. Now this is something which is doable. Three prime numbers p, q, and r, each less than 20, are such that p minus q equal to q minus r. How many distinct possible values can we get for p plus q plus r? So basically, you can see p, q, r are in arithmetic progression. Their difference is same. So now let's write all the prime numbers less than 20. Right? 2, 3, 5, 7. 2, 3, 5. Acha, can you see that p plus q plus r is actually equal to 3q? So we simply have to find distinct values of 3q, right? 2, 3, 5, 7, 11, 13, 17, and 19. Right? So again, the trick here is to find p. If p is 2, you cannot have 3, you cannot have 5. In fact, you cannot have anything, I think, because the common difference will always be odd, and odd plus odd will be even. So eventually the last number will become even. Let's take p3. Then you have 3, 5, 7. And this becomes 15. Right? 3, 7, 11. 21. Do you have anything else? 3, 11, 19. Yes, 3, 11, 19. This becomes 33. Right? This becomes 33. Do you have anything else for 3? No. Take p equal to 5. So 5, 6, 5, 11, 17. You get 33 here. Right? You wanted to have distinct possibles. So you cannot count this again. You cannot count this again, guys. Right? I hope I'm making sense. You cannot count this again. Okay? Okay? You cannot count this again because the difference is same. Okay? Right? Do you have anything else? Do you have anything else? 7, 13, 17. 6, 7, 13, 19. Right? Is another one which will give me 39. Which will give me 39. Okay? Right? Am I making sense? Am I making sense, guys? So now just see the answer. Answer is D. It is more than 6. Oh man. So which means we have to count many more. We have to count many more. Actually, we have to count many more. Distinct possible values can we get? How many distinct possible values can we get for p plus q plus r? 3 prime numbers p, q, r. I don't think we will have more. 13, 17, 19. We cannot have 17 as the number. We cannot have 19. See, like what I'm seeing here is it the middle possibility? No, this cannot be in the middle. This we have already counted. 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 This can be in the middle. These are the 4 only options, right? The answer has to be 4. Maybe I have the answer key wrong. The answer has to be 4. It cannot be more than 4. It cannot be more than 4. Right? And p is bigger than q. So actually, you could have written it like this. So basically, I have taken p as the smallest number, but they are saying p is the largest number. Right? P is the largest number, which will make absolutely no difference. Which will absolutely make no difference. Like you can assume p like this, q like this, r like this, which will not like it will not make any difference. The answer will be 4 only. Okay. Now, how many distinct possible values of p plus q plus r are there satisfying 1 by p plus 1 by q plus 1 by r? 100% skippable problem. skip. You'll not be able to do it. Believe me, you'll not be able to do it. This is a very, very difficult problem. Very, very difficult problem. So we have done like out of the 3 problems, we have just been able to do 1 in 2025. Team X scored a total of n runs in 20 overs. Team Y tied the score in 10% less overs. Had Team Y average run rate been 50% higher, the scores would have been tied. This we can do. Now, can you do it? I'll just take 2 minutes break. Right? I'll just take 2 minutes break to fill my water bottle. Done? Not attempted yet? Let me attempt it then. Let me attempt it then, guys. Okay. So, Team X scored a total of n runs in 20 overs. Team Y tied the score in 10% less overs. Had Team Y average run rate been 50% higher, the runs scored would have been tied in 12 overs. Okay. So, Team Y tied the score in 10% less overs. So, basically, X team made n runs in 20 overs. Y team made n runs in 18 overs, 10% less overs. Right? So, their run rate was n by 20. Their run rate is n by 18. Okay? This is run rate. Basic knowledge of cricket is required here. Basic knowledge of cricket is required here. Okay? Had teams Y average run rate been 50% higher, 50% higher means 1.5, right? So this becomes n by 12, right? How many runs were scored by teams? So the scores would have been tied in 12 overs. It is written 12 overs. It is coming out to be 12 overs. How many runs were scored by team X? So n belongs to real number. N is coming out to be real number, right? Because it is coming out to be 12 only. It is coming out to be 12 only, right? Then this information is correct. So everything, every number will satisfy. So it is cannot be determined, right? Like I said, cannot be determined. Basically, we had to find an equation in which n can be determined. We are not finding any. We are not finding any, right? I hope I'm making sense. So this was a doable problem. So this is 2 out of 4. Now, like I said, percentage problems always we have to do. Price P of commodities first increased by k%, then decreased by k%, and it's a repeated concept, right? Increased by this, again decreased by this. If the new price is Q, what is the relation between this? It is very much visible. 100 plus k square into 100 minus k square q into 10 to the power 8. So P 10 to the power 4 minus k square whole square. Right? A answer. 100% doable problem. 3 out of 5. 3 out of 5. Right, guys? Right? Am I visible as well as audible? Are you guys following it? Are you guys following it or not? Are you guys following it or not? Now, so see, like we are doing the second paper to understand the relation, to understand which topics are repeated. This is a repeated problem. So can you simply jot down this formula? Perfect. Okay. Let's move on to the next one. Let's move on to the next one. 3 out of 5 till now. The petrol price shot up by 10% as a result of hike in crude oil prices. Reality of today. The price of petrol before the hike was 90 rupees per liter. A person travels 2200 kilometers every month and his car gives a mileage of 16 kilometers per liter. By how many kilometers should he reduce his travel if he wants to maintain his expenditure at the previous level? Again, a very simple problem. All you have to do is to just simply do the math, right? 10%. So now the new price is petrol old was 90, petrol new is 99. Okay. Okay. So what he is saying, a person travels 22 kilometers. So this is the liter of petrol which he consumes, which he used to consume earlier, right? And this used to be the price earlier which he was paying. Now his new consumption is N and the new price is 99. So what do we have to do? We simply have to calculate N. Now you know the table of 11, right? So this becomes N is 2000 by 16, right? This is the liter. This is the new liter which he is consuming. So basically 2000. So right. So basically he is 16 and 16 will get cancelled, right? Because the mileage will not improve. So he will have 2000. He will have to travel 2000 liters. 2000 liters now. 2000 liters. 2000 kilometers. Now, so this is the thing, right? So basically, see, like, I could have done it in a very easy manner. If the answer is B, yes, the answer is B. See, what is happening? Petrol is becoming 1.1. Petrol is becoming 1.1. So the distance, increase the distance to 10%. So we have to do this type of multiplication. Means if now he is traveling d distance, earlier he used to travel 1.1 d, because the product of these two should be same. See, like the product is 1.1 pd, 1.1 pd. So if this is 2200, this has to be 2000. So the difference is 200 kilometers. This is usually how people do who have very fast calculations. Like I do it like this. While explaining, I'm explaining it to you like this. But those who have great understanding of numbers will do it like this. Right? 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 But this is a doable problem. Till now, we have simply skipped two problems. Okay. Okay. Let's do it. Now, we saw a remainder problem in 2022 as well. This is the similar one. A 4-digit number n is such that when divided by 3569, it leaves a remainder 1347 respectively. Right? What is the smallest value of n? Now you see, I am writing divisor here, remainder here. Divisor is 3, remainder is 1. Divisor is 5, remainder is 3. divisor is 6, remainder is 4, divisor is 9, remainder is 7. If you see D minus R is always 2, is always 2, right? In such cases, the smallest number is, right, the smallest number. So if you see properly, this number is n is 3 times plus 1. So n minus 1, in fact, n plus 2 is 3q1 plus 3. Just look very carefully. Just look very carefully. Now, I can do it by my technique also, by of checking the option. You will always get the answer checking the option, right? So, if you subtract 1, simply subtract 1 from everywhere. 1067. This is not divisible by 3. Because see, like if it is like just simply giving me the remainder 1, right? Giving me the remainder 1 upon division of by 3, then after subtracting 1, it should be divisible by 3. 1071 is divisible by 3. 1077 is divisible by 3. 1081 is not divisible by 3. So it is either of these two. Now I will look at 9. I will subtract 7. So 1065 and what is it? 69. Right? I'll subtract 7. 1071. So this is divisible by 9. This is not divisible by 9. So this is my answer. This is my answer. Otherwise, if you want to know the general logic, then n plus 2 LCM will be equal to n plus 2. Simply. Their LCM 3569. What is the LCM? 9 into 5. 45 into 2. 90 is the LCM. So 90. So n plus 2 equal to 90. N becomes 88. And this is your general term. This is your general term. Right? Right? This is a repeated problem. This is a repeated problem. Last time also we were able to do with options. This time also we are able to do with options. Now, what is the unit digit? What is the unit digit of the multiplication? Right? It has to be 5. The number is divisible by 5. Highly doable problem. 6 out of 8. We are rocking here. 75% of the paper we are able to do till now. What is your opinion on this? Is it a do problem or a skip problem? Is it a do problem or a skip problem? Tell me. Tell me your honest opinion. Tell me your honest opinion. It's a do problem, right? Now, moving on. Consider the first 100 natural numbers. How many of them are not divisible by any of 2, 3, 5, 7 and 9? Right? 2, 3, 5, 7 and 9. Right? So basically, see, what is the way to do it? 100 minus, let's divide all, let's subtract all multiples of 3. I've done it. I've done it. Right? So, and then, so this is 50. Now all even numbers are gone. All even numbers are gone. Now what I have not divided is these 3 numbers. These numbers, right? Which are not even but divisible by 3. Which are not even but divisible by 3. It will go till 99. Right? Now let me tell you the counting technique. Just add 3 here. You will find the beauty of it. I have added 3 here. Now divide by 6. Why am I dividing by 6? Because the difference here is 6. Right? So when you divide it by 6, you get, so how many numbers are these? 70. But this is a skip problem. This is a skip problem. I'm simply doing it for the sake of it. It is a skip problem. Right? Now, Just see. 5, it will be very simple now. It will be very simple. Don't worry. It will be very simple now. Right? It will be very simple. Or other than how it becomes a do problem, let me tell you. See, basically these are 4 prime numbers. You don't have to worry about 9. Right? Just see multiples of 11. 11. Right? Now 11 times 2 will not come. 11 times 3 will not come. 11 times 5 will not come. 11 times 7 will not come. Okay. 13. 13 times 2 will not come. 13 times 3 will not come. 13 times 5, 13 times 7 will not come. So essentially, is it asking me prime numbers? All 2-digit prime numbers? Is it asking me only this? Just tell me. All 2-digit prime numbers. Is it asking me all 2-digit prime numbers? Just tell me. There are 25 prime numbers from 1 to 100. Minus 4, 21 is your answer. If somebody can think it like this, then it becomes a do problem. Were you able to do it like this? And 1 also has to be included. 1 also has to be included, guys. 1 also has to be included. Right? 1 also has to be included. So it will become 22. It will become 22. It will become 22. Is it a do problem or a skip problem now? I think it is very difficult to think it like this. It is very difficult to think it like this. So we'll just give the benefit of doubt to it. Right? So 6 out of 9. 6 out of 9. Okay. Now, D, let's see this. X 4 to 8, Y. What is the ratio of maximum and minimum value of X plus Y? Now, it's very simple. What is the ratio of maximum value of X plus Y? So, X plus Y maximum is 50. Minimum value of X minus Y is 4 minus 7 minus 3. So, it becomes minus 5. Right? Maximum value of X plus Y is 50. You take the maximum of these. Minimum value of X minus Y. Minimize this, maximize that. X minimum is 4. Y maximum is this 7. So 4 minus 7 is minus 3. So you will get minus 5. Highly do problem. Just that answer is none of the above. Highly doable problem. It's a do problem. Right? It's a do problem. It's a do problem. Okay. This becomes a do problem. Are you getting it? Are you getting it? Right? Okay. Just a second, guys. I'm just checking the link. Okay. Perfect. Right? Now, let both P and K be prime numbers such that P square plus K is also a prime number less than 30. What is the number of values of K? Right? Right? Now, would you agree that, see, like, if P is even, P square is even, and then K has to be odd. So P even is only 2. So 4 plus K is prime. Isn't it? 4 plus K is prime. And K has to be prime. So K can be 3? Yes. Can it be 5? No. Can it be 7? Yes. Can it be 11? No. Can it be 17? No. Can it be 19? Yes. Yes. Because I'm seeing, see, like K plus 4 has to be prime. Can it be 23? No. That's it. That's it. Right? Now, if P is odd, K has to be even. So this gives me Q square P square plus 2. Oh, so we are just asked now, but you have to have. So 4 is the answer, right? Number of values of K. So K was 3 here and then 1. 4 answer. 4 is the correct answer. One more is coming. Is like what are we skipping? What are we skipping? Let's see. Are we skipping something here? Are we skipping something here? We have to see. 4 plus 1. See, like I have taken P to be 2. 4 plus K is prime. 4 plus K is prime. What are we skipping here? See, like we have to skip here. Like we are skipping something here. Let's check again. 3 is done. Right? 7. You cannot take K1. Okay. 5 you cannot take. 7 you can take. 9 is not a prime number. 11 you cannot take. 13 we have missed. We have missed 13. We have missed 13. 13 was also there. 13 was also there. So 5 possible values. But again, this is in my opinion, it's a doable problem. It's a doable problem. 7 out of 10. It's a doable problem. It has to be a doable problem because it was not lengthy to understand. The prime numbers, and if you see, this is the distinct difference between 2023 paper, 2022 paper, and 2025 paper. Till now, we have faced 3 prime number related problems. The concept of prime number, right? And they will pick one of the concept and they'll ask repeated problem from it. Okay, there are n sets of numbers, each having only 3 positive integers with LCM equal to 1001 and HCF equal to 1. What is the value of 9? And it has to be a skip problem. It has to be a skip problem because see, like 1001, you have to know that it is 7 times 11 times 30. It is 7 times 11 times 30. Right? 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 And their HCF is 1. So are you, and see, like their LCM is 1001. So one set is this, one set is this, one set is this. Not 13, 13 times 11 is 143. 11 I have taken, so 91. 1. One is this, 1. Oh no, 3 distinct integers is asked. So 17, 143, 111, 91, 113, 77. Right? So these are the 4. These are the 4 possible ones. Right? Everywhere LCM is 1001. So basically we have to divide like powers of 7 and powers of 11. Okay. Three positive integers. I think they are considering it also. They are considering it also. Otherwise, there is no way of getting more than 4. 1001 is 7 into 7 times 11 times 13. So it becomes a skip problem. Like we are not able to find any of the options. Right? So it becomes a skip problem for us. Because 1001 is 7 times 11 times 30. Okay. And like breaking it into product of 3. How do I break it into 3? I don't think there is more number of ways than this. What is the answer given? D. More than 8. More than 8. See, like I'm pretty sure they are considering the arrangements. Like they are considering this as different. That is how they are getting more than 8. Otherwise, how do you get more than 8? How do you get more than 8? Because all these three are prime numbers only. You cannot further disintegrate them. So this is a skip problem. So 7 out of 11. Now, this is an easy problem, right? What is the maximum value of n such that, so you just simply have to factorize it. How many, see, like 35 is made from 7 and 5. So how many 7s are there? How many powers of 7 can you find? 1, 3, 4, right? There is 135 here. This is 35 times 11, right? So you have 135, just ignore it. You have 3 5s here. And then there is no 5. Lot many 4s, but no 5s. So you just combine these three. So you have 35 to the power 4 here. Right? So in this case, in this product, 7 is in excess. We just have to count how many 5s can you have. Because you will be able to make only those many 35s as per the number of 5s. If you have 4 5s, then you will be able to make 4 35s. Right? Right? Are you getting it? Are you getting it, guys? Because see, like there are so many 7s here. 1 7 is here, 3 7 is here, one more 7 is here. 4 7s are. This is 7 to the power 4. So lot many 7s are here, but you have only 4 5s here. 1 power of 5 here, 3 powers of 5 here. So in total, you will have at max, you will have 4 powers of 5. Getting my point? Are you getting my point? So B is the correct answer. Now, how many are we able to do? So this was 12th problem and we are able to do 8. Like we have back to back, we have skipped 2 problems. Again, we are maintaining our ratio of 2 by 3. That is 66%. 66%, right? Okay. Now, let's come back to what is the X in the sequence? What is the X in the sequence? 12, 18, 36, 90. Now, again, you will find exact same logic which we discussed in 2022 paper. It is exact same logic. 24 times something times 1 is 12. 12 times 1.5 is 18. 18 times 2. So this has to be 0.5. This will become 12. This will become 12. So the answer is 12. Exact same logic. That is why this session is very, very important. We had the exact same logic, right, in 2022 paper as well. And PYQs are always important, be it any exam. Any objective, for any objective examination, you just have to assume that the paper making authorities are very lazy. They will pick a concept or two from the PYQs. Right? They cannot give problems from new topics always. Right? Same logic. Right? We just studied it in the first question. Exactly same logic. Right? Now, round problem. Again, same logic. P and Q walk along a circular track. They start at 5 a.m. from the same point in the opposite direction. P walks at an average of speed of 5 rounds per hour and Q walks at an average speed of 3 rounds per hour. How many times will they cross each other between 5:20 to 7 a.m.? Now, can we do it again by my logic? Right? Right? What was my logic? What was my logic? I will keep it static. I will keep it static. Right? Which one? This Q guy. So now, but now they are walking in opposite direction. This guy is having 5 rounds. This guy is having 3 rounds. So effectively, 8 rounds is their speed. Now P is moving with P rounds, with 8 rounds per hour. This is the speed. Right? 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 So now how much hours are these? 520 from 520 to 7. Can you see that this is 1 hour 40 minutes? Means 100 minutes. 100 minutes. Right? Right? Please look carefully. So this guy was doing 8 rounds in 60 minutes. Right? 8 rounds in 60 minutes. So in 1 minute, he will do 8 by 60 rounds. In 100 minutes, this guy will do 800 by 60 rounds. So if you see carefully, this becomes 13 point something. 13 point something. So just see. This guy is stationary. Now P along the circular track from the same point in the opposite direction. Right? Cross each other. So like this is the first one is not considered crossing. Now 13.3 means 13 times he will cross Q. Are you getting my point? Same logic, exactly same logic. Exactly same logic. Yes, Amrendra Pratap Singh, yes. But like we were not able to do that. So that is why I have kept it in skip category. I was not able to think it like that, right? 7, 11, 13, right? You are correct. You are correct. You are correct. But like if that is a do problem, then it's very good. Then your level of mathematics is very good, actually. Right? But this is nice one. Like this is the same technique which I taught in the other problem. And you can see there is a template following. There is a template getting followed. Right? One type of problem. They will ask one type of problem in every paper. In 2022, they asked it in a different manner. Here, they are asking it in a different manner, but the concept remains the same. Right? B is the correct answer. Okay, now a tram overtakes 2 persons. So we were at 9 out of 13. 9 out of 13. Okay. A tram overtakes 2 persons X and Y walking at an average speed of 3 and 4 in the same direction and completely passes them in 8 seconds and 9 seconds respectively. What is the length of a tram? What is the length of the tram? Okay. So now what we will do, first of all, see like this is it will have a lot of fractions, right? Meter per second. So if I first of all 3 times, this is kilometers per hour, right? So I will multiply it with 1000 meters and 3600 seconds, right? So this is 5 by 18 basically. Okay. So this guy is moving at a speed of 5 by 6 meter per second. And this guy is moving at a speed of 10 by 9 meter per second. Right? 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 Now, let the speed of tram be u. It is moving like this. Again, concept of with relative to this person, the speed will be u minus 5 by 6 and it is taking 8 seconds to cross it. 8 seconds to cross him. But if the speed gets subtracted by like this, it is taking 9 seconds to cross it. This will give me the idea of u. Right? This will give me the idea of u. Okay. So this will give me 8u minus 40 by 6 is equal to 9u minus 10. 9u minus 10. So this gives me u equals to 20 by 6. That is 10 by 3 meter per second. And if you see, this is the length only. The length is this only. So length is 2, 20 by 6 minus 5 by 6 into 8. This gives me 15 by 6 into 8, 120 by 6, 20 meter. I would consider it as a medium problem. Simply two equations are involved, but in the context of the paper that we are seeing, this is a highly doable problem. I would say it is a highly doable problem. What is your take on it? What is your take on it, guys? Is it a doable problem? I think it is a doable problem. I think it is a doable problem. Right? It's a doable problem. Next up. Oops. Now this is you would not believe, this is a concept given in 8th class NCERT. Chapter name is the second chapter, square and square roots. If it is till 9, it will be 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the one. Right? Highly doable problem. Highly doable problem. Isn't it? Class 8th, chapter 2, square and square roots. By the way, guys, you people know, right, that the NCERTs have changed. NCERTs have completely changed. Right? You know this thing, right? Okay. Now, a set X of 20 pipes can fill 70% of water in okay, third set. Now you would think that this is a difficult problem, like, because it is looking a very lengthy problem. But I will take it. Actually, it is a lengthy problem. Like it will have lot of calculations. Like you have to process this, then you have to process this. So like it, I think we should skip it. Although it can be done. Like I'm saying, in the second round, if you have time, you should be able to do this. It's not very lengthy problem, but then you'll have to make 3 different calculations. Right? Because see, like it involves you to, so let me do it for you. Like let me still do it for you. Let me tell you how to think smart in this. First of all, I have seen half of the pipes of set X are closed. So only 10 pipes are running. So 20 pipes. First of all, get your calculation to a minute. 70% in 14 minutes. So 5% in 1 minute. Okay. So if 10 pipes are working, 2.5% in 1 minute. Am I making sense? And everything is in fraction, so convert it into a fraction. 1 by 40 in 1 minute. Okay. This is X. This is X. Now let's talk about Y. Half of the Y are open. Now what is a Y doing? 3/8 of the tank in 6 minutes. So in 1 minute, it is doing 1 by 48, 3 by 48, 3 by 8 into 6 in 1 minute. Right? This becomes 1 by 60, and half of the pipes are working. Half of the pipes are working. So 1 by 32 in 1 minute. Okay, this is Y. This is contribution of Y. Now Z, everything is working, right? If half of the, and what is about Z? Third set Z of 16 pipes can empty half of the tank. So it is actually reversing. So first two are filling and all pipes are, then how long will it take to fill 50% of the tank, right? So 16 pipes can empty half of the tank in 20 minutes, right? So in Z, you have to take subtraction. 16 pipes can, and all the pipes are working. So in 20 minutes, they can half the tank, they can they can completely empty half of the tank. So 1 by 40 minute in 1 minute, basically. So simply 1 by 40 plus 1 by 32 minus 1 by 40. This is the amount of time. This is the minutes which it will require to completely fill. Since you are asked half, answer will be 16. So there are a lot of unitary method. This is called unitary method. Unitary method, right? The key concept here was to bring down the level, to bring down the calculation to 1 minute. Are you seeing it? And this is precisely how time and work problem works also, like the men-women problem. So the men-women problem is considered similar to this problem, right? Yes, this is for round 2. This is for round 2, guys. Yes. Like I said, D is the correct answer. So how many we have done? 15, 16. So 11 out of 16 till now. 11 out of 16 till now, right? If n is a natural number, then what is the number of distinct remainders of 1 to the power n? Oh man, just simply keep n equal to 1. 3 will be the remainder. N equal to 2. 1 will be the remainder. And it will always be odd. It will always be odd. So remainder will be 1 and 3. So 2. Highly doable. Highly doable. Right? So 12 out of 70. Single line problem, single line solution. Right? Now let's do this. P, Q, Q, Q be a 3-digit number. What is the HCF of P and 481? So now Q is a 3-digit number. So this is Q into 111, Q into 3 into 37, right? It is asking HCF, right? Now what is 481? 481 is 1, 30, 11, 40, it's not, what am I doing? 13 into 37, right? So 37 is definitely an HCF. Highly doable. What was the score here? 12, 13 out of 18. 13 out of 18. Highly doable. Isn't it, guys? Isn't it, guys? Highly doable. What is your opinion on it? What is your opinion on it? I think it is highly doable. I think it is highly doable. Okay. Now, what is the 489th digit in the number? Now, this is doable but very lengthy. This seems to be very lengthy problem. Now, what I will do here, I will see that 1-digit numbers are 9 here. 1 digit, right? Then 180 digits will be occupied by 2-digit numbers. What are 2-digit numbers? 10, 11, 12 till 99. So these are 90 numbers. They will occupy the next 180 digits. So they are 189 digits. These are 189 digits. Now, how many 3-digit numbers do we have? How many 3-digit? We have so many 3-digit numbers, by the way, right? So now let's see. 101 to 200 will occupy next 300 digits, right? 100 times 3, and that is it. This becomes 489. We are lucky. So my 100 digit is 0. I am lucky, right? We committed to this problem. We were able to solve it. Sometimes you have to enter the battlefield to win. And this is one such problem. Right? 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 D. Oh, D. How can it be D? 9 digits and then, oh, I missed on 100. I missed on 100. See, but this is the silly mistake which I made. This is the silly mistake which I made. It is actually, it has to start from 100, right? 100 to 199, then 9 will be the number. My bad. And like, see, they made 0 as first option so that people can do the silly mistake which like I did. Right? So 9 is the correct answer because we had to start. See, like we were doing all along, we were doing it correctly. 2-digit numbers till 99. So we had to start from 100, not from 101. So from 100 till 199, there are 100 numbers, 300 digits. So the 300th digit will be this one only. Right? Right? Okay, perfect. So how many problems? This is a doable problem. 19, 14 out of 19. 14 out of 19. Let's do it. Again, time and work, similar problem. X can complete 1/3 of a certain work in 6 days. Y can complete 1/3 of the same work in 8 days. Z can complete 3/4 of the same work in 12 days. Okay. All of them work together for n days. And then X and Z quit and Y alone finishes the work in 8 2 by 3 days. It is a skip problem. Believe me, it is a skip problem, right? Although it can be done. How it can be done? Let me tell you. X can complete 1/3 of his work in 8 days. So basically, X need 18 days to complete a work, right? Y need 24 days to complete a work, right? We have to think it like this. Okay. So in one day, it is completing 1 by 18 work. In one day, it is completing 1 by 24 work. Z can complete 3/4 of the same work in 12 days, right? So you have to think properly to come up to the conclusion that Z will require 16 days to complete the full work. Now, for n days, all of them are working together. See, like in one day, X is putting this much effort, Y is putting this much effort, and Z is putting this much effort. Right? So for n days, they are putting this much effort. Okay. So this is the fraction of work which is getting completed. In 8 2 by 3 days, that is 24, 26 days, 26 by 3 days, Y is working alone and this is equal to 1. This is equal to 1. This is the thing. Okay. Damn it. Now let me tell you a manipulation here. Just simply multiply it with 144. 144 is the LCM. This is the manipulation. Okay, when you do it, take 144 inside. 144 becomes 8 here, 6 here, and 9 here. 144 when gets multiplied here, 24, 3, 72, 52. 144. This becomes 82, no, 92. And this becomes 23n. So n becomes 4. Did you like the manipulation of multiplying 144? This is a very amazing manipulation. 144. Because see, like we Indians do not like fractions. We think we like things in whole. So we'll make it whole. So 4 is the correct answer. This was amazing manipulation. This was amazing manipulation. Right? But this is this is a round 2 problem. What was it? 14 out of 19. So 14 out of 20. Let's keep it for round 2. I've still taught you, because why I told you this method, because I am seeing time and work problem coming again and again. And did you see a shift in pattern here? In 2022, there were very lengthy looking problems. In 25, the problems are not looking lengthy. Conceptually, they are heavy. Okay. Now let's do it. Again, 1, 3, 6, 11. Whenever you see an increasing thing, just try to do it like this: 2, 3, 5, 7. It's completely a prime number. Prime number logic, right? 2, 3, 5, 7. And then you have 11. So this will give a 29. Highly doable problem. Prime number. This is the fourth problem of prime number that we are doing in this particular paper. Fourth problem of prime number that we are doing in this paper, right? So 29 is the correct answer. 29 is the correct answer. 29 is the correct answer, right? Okay. What is the remainder when this is divided by 6? Right? Divided by 6. How many numbers are these? So see, like, obviously, this number is divisible by 3, this whole number. How many numbers are there? How many numbers are there? These are 98 numbers. Now, what is the ninja technique of doing this? Just see the powers. Highest power minus lowest power plus 1. Right? 98. So 98 odd numbers add to an even number. So this whole number is even. It is divisible by 3. An even number divisible by 3 is a number divisible by 6. Hence, remainder is 6. Remainder is 0. Highly doable problem. Highly doable problem. Where were we? 14, 15 out of 21, 16 out of 22. 16 out of 22. We are making a very healthy ratio. We are maintaining a very healthy ratio. Isn't it? Isn't it? In 2026, I think lengthy questions will not be asked. Conceptually heavy questions will be asked. Because in 2024 also, conceptually heavy questions were there. I could see conceptually heavy problems. Right? Right? The average of three numbers P, Q and R is K. P is much more than the average of S, Q is less than the average. What is the value of R? What is this? The average of P, Q and R is K, right? P is as much more than the average as Q is less than the average, right? So P is K plus D, Q is K minus D, which means R is equal to K. They are in AP. So it is, see, highly doable problem. So 17 out of 22. Right? 16 out of 21 was our ratio. 17 out of 23, my bad. 17 out of 23. Some problems are very simple here. Some problems are very simple. This was a simple problem. This was a very simple problem. Right? Now let's do it. The difference between any two natural numbers is 10. What can be said about the natural numbers which are divisible by 5 and lie between these two numbers? Right? Right? Now see, if the numbers are 10 and 20, there is only one number. If numbers are 11 and 21, there are 16, 15 and 20. Right? What can be said about the natural numbers which are divisible by 5 and lie between these two numbers? There is only one such number? No. There can be more than one such number. Simple. See. Highly doable problem. Again, highly doable problem. 18 out of 24. Right? 18 out of 24. So this is over. That's it, guys. So in 2025, there were 24 problems. That is 30% of the paper. Out of that, you are able to do 18. That is 75% of the problems you are able to do. 75% problems you are able to do. Rest of the problems are mental ability. They are, believe me, they are easier than this. Like that, what do you call it? Basically, see, like 60% of the paper is mathematics and mental ability. The mathematical part was 24 questions in this particular paper. That is 30% of the paper. The mental ability part, that age problems, blood relation problems, all those problems were again another 30%. Another 30%. So in total, we usually see 40% of the reading comprehension, 60% of the mathematical part. right? So I hope, guys, I am able to tell you certain things. This is it from my side. I hope like you were able to understand few things here. I hope you were able to do few things here, right? Any takeaway you have, you can write it in the comment. I will definitely try to do more sessions, but since 24th is coming, I wanted to do this particular session in which I can tell you certain strategies. Key takeaways from this session. First key takeaway from this session, you should know which problems to skip. Two type of problems. One, very lengthy looking problem from the question itself. Second, which involves 5 or 6 variables. These are the two important phenomena. We have noticed that not all problems can be done. This is a qualifying examination, which means you should not be going after each and every problem. One important piece of advice I want to give you all: do not get stuck on any problem for more than 1 minute. If you are not getting any idea for 1 minute, skip it. If you are completing a calculation, you can give 1 additional minute to it. Other than that, do not do any, like, do not get stuck in any question. Right, guys? Okay. Thank you. Thank you. Thank you, guys. I'll just simply write to the people there. Where's the CSAT guys? Thank you, guys. Thank you. Thank you for all the love. I'm waiting for them to end the stream. Right? I'm waiting for them to end the stream. I'm just waiting for them to end the stream. थैंक यू, थैंक यू. हिंदी में भी भाई सभी लोगों को ऑल द बेस्ट 24 तारीख के लिए. सभी लोग अच्छे से करके आना यार, और मुझे बताना क्या कुछ ना कुछ क्वेश्चन तो हमारे जैसे आ जाएंगे बिल्कुल. These people are not picking up the call. Yes, they are ending the stream, guys. They're ending the stream. It can be. Yes, I'm still live. You are on Unacademy English channel. How will you understand English? How will you understand Hindi then? Just a second. Yes, Rajat, can you end the stream? अच्छा, okay.